Who can explain to me what a nebula is? What happens when a nebula is produced in the outer space? Penny? Right, so I don't know, a lot of people have seen Star Wars or something of the like where the stars kind of goes and kind of blows up. So the star is like sort of ending its life out in outer space and it burns up. And that's why you see all the radiant light coming from it. And then eventually it's gone, but things move a lot slower in space. Okay, asteroids. We have asteroids, meteors, and comets.
I'm used to designing stunning spaces, but when tax season for my business comes around, even I need some help. This year, I can...
Hello everyone, and welcome to our universe. Today we'll be answering the question, what is a comet? So comets are basically dirty snowballs which orbit the sun. They are generally made of ice, such as water, carbon dioxide, ammonia, and methane, and mixed in with a bit of dust. These materials come from a time when the solar system was barely formed. Comets have an icy center, called the nucleus. And this is surrounded by a large cloud of gas and dust, called the coma. The coma is created as the ice in the nucleus is warmed up by the sun and evaporates. Comets can develop two tails as they travel closer to the sun. The straight tail is the gas tail, and the curved tail is the dust tail. The gas tail is created by the solar wind. This pushes gas away from the comet's coma and pointing it straight back from the sun. The dust from the coma is not affected by the magnetic fields, but is vaporized by the sun's heat, and this forms a curved tail, which follows the comet's orbit. So, I hope that's given you a good insight into what is a comet. And of course, if you'd like to know any more about comets, I'll put some links in the description below.
So what causes the comet to have the tails? Do you remember what it said? Yes, Jace. Right, so a comet is made up of what? Yeah. Dust. There's a couple other things. Gas. Jackson. Water. Jason. Ammonia. There's one more. Do you remember? Go ahead, Landon. Carbon dioxide. Yep, so all of that stuff is formed in outer space into this big giant, what he said was a dirty snowball. So how do we know that water reacts when it gets heated? It melts. Okay, what happens if it's overheated? If you left a pot on your stove and it got heated and heated and heated, it boils, what happens to that water that goes into the air? It evaporates, good. So our comets are basically evaporating in outer space, which is leaving the tail of the gases and leaving the tail of the dust that's left over after the water evaporates. Okay, so some people have seen shooting stars, some people have seen comets, some people have seen meteoroids. So let's figure out what the difference between asteroids and meteoroids is. So asteroids are small rocky objects that orbit the sun. Although asteroids orbit the sun like planets, they are much smaller than planets. What do you think would be the difference between an asteroid and a planet like Earth? Do you see any differences? Yes. It's smaller. Jackson? Right, there's no color. So what does that mean? If we're looking at Earth from outer space, what do the colors represent on Earth? Water. And like what makes the green part? Trees and stuff. Do we see any blue or green on this asteroid? No. No water, no trees. So we'd assume there would be anybody living on an asteroid? Chase. It does have craters. Yep, I would assume that life would not be able to live on an asteroid. Then we come to our meteoroids. So meteors and meteoroids are space rocks. So they range in size from dust grains to like huge boulders. And if it's an asteroid, it only applies as that name when that ball or that rock is in outer space. Once it comes into the Earth's outer space and down to the Earth's surface, it is called a meteor or meteoroid. So here's an example of a guy. You know, sometimes you can go out, if you see a meteoroid fall, you can sometimes go find it. I've never been able to when I've seen them, so. But I guess if you know how to find them, you might be in better luck. But have you ever seen a meteor shower where you get out at night and you can see all these like bursts of light in the sky? That's so cool. I remember seeing one of those when I was in Wisconsin one year. But all there are is asteroids floating in space and coming down, and the Earth's gravity pulls them into our atmosphere and down to Earth. Yes, Jace? Oh, nice. Jason? I mean, it is kind of scary, but when you think about how far away those things are, because from where we're standing on Earth all the way to our outer space, it takes a while to get there, right? So not every asteroid is going to become a meteoroid or a meteor, because not all of them are going to enter our atmosphere and come down to Earth. Some of them are going to pass Earth up because they're that far out from us that they won't enter the atmosphere. Does that make sense? Okay, so stars are balls of gas that are either close to the Earth, so they seem bright, or they're farther from the Earth, so they seem a little bit dimmer. Let's find out.
Let's talk about what your car means to you.
Do you think you know what kind of star that is?
Like fireflies on a still summer night, they gently dot and illuminate the infinite velveteen sky. Stars, be they millions or billions of years old, are all born in nebulae, clouds of dust and mostly hydrogen gas. Within these stellar nurseries, stars begin life as protostars, or hot cores formed by the collection and collapse of dust and gas. As the protostars become hotter, hydrogen nuclei inside of the cores begin to fuse and create helium. It is this chemical reaction, thermonuclear fusion, that generates a star's heat and energy and causes it to shine. Stars are categorized by a number of characteristics. One of these classifications is by surface temperature, called spectral classes. These 7 major groups range from the coolest stars, which are designated as M, and up to the hottest stars, which are designated as O. Stars are also classified by the amount of light they emit, or luminosity. Called luminosity classes, these 9 major groups range from the small, less bright white dwarfs to the large and extremely bright hypergiants. But no matter the luminosity or surface temperature, all stars eventually burn through their hydrogen fuel and die out. Less massive stars, such as our Sun, release their stellar material into space, leaving behind a white dwarf surrounded by a planetary nebula. More massive stars instead blast matter into space in a bright supernova, leaving behind an extremely dense body called a neutron star. But the most massive stars, stars that are at least 3 times our Sun's mass, collapse into themselves and create a bottomless well of gravity, a black hole. But from the remnants of stars, heavier elements are cast into the universe, and it is this stardust that form the seedlings of life itself.
Okay, so there were some big words in there. Let's pause and talk about some of those things that you may not understand, okay? So, does anybody have any question about the terminology that you used in there, like thermonuclear or anything like that? We understand that a star